plus CXS plus KXS is equal to FS. Simplify. Now take x power s common. What is inside left? ms square plus c plus k. There should be an s here. So cs plus k should be equal to fs. So you have ms square plus cx plus cs plus k equal to. Now this is our equation. So before we go further, let's repeat what we have done. This is the problem. Forces and displacements are given. Initial conditions are given. You apply Newton's law. When you apply sum of forces equal to mx dot, double dot, you simplify the equation, you end up with this equation. This equation is simply, I rewrite it, making sure that I understand that the first and second derivatives are also function of time. So I put function of time, function of time, function of time, function of time. Then I take Laplace of both equations. Now Laplace of second derivative is given by this equation. Laplace of first derivative is given by this equation. The Laplace of simple xt is given by this, and function ft is given by this. I substitute those values back into this equation. Then I apply my initial conditions, three terms vanish. Then I am left with this equation. I take xs common. Then I have this equation. I proceed further from here. Now what I do, I divide these two functions. So I will say that xs over fs will be equal to 1 over ms square plus cs plus k. This ratio is called the transfer function. This is your transfer function. This is called transfer function Ts. This is my transfer function represented by Ts. ms square plus cs plus k. Now I can simplify it if it is difficult, but in this case it may not be that difficult. So what I do, let's assume, so this is my transfer function. Now what is xs? So this is the definition of transfer function. Now how to solve? Look, your xs equal fs over ms square plus cs plus k. From this equation, xs will be equal to this. Right? So with this equation, first of all, I find the transfer function. And second thing I did, I just find xs is equal to fs. Let's assume that fs is given. This is the function which is given. Basically, it's a Laplace of the given function. Right? If I give you sine t, the Laplace will be 1 over s square plus 1. Right? Whatever I give you here, you take Laplace, it will be the value of this. Right? Let us assume, to solve this problem, let us assume that our transfer function, our fs is given as s plus 9. let's assume, this is an assumption, but if I give you ft, you should be able to get fs. Let's assume that for this it is s plus 9. And let us assume that m has a value, c has a value, and k has a value. So let's assume that m is equal to 1 kilogram, and c is 7, and k is 6, spring constant. You put all these values there, you have s plus 9 over s square plus 7s plus 6. This is your Laplace. Now you take inverse Laplace. So take inverse Laplace. Here you will get xt, and here you will get inverse Laplace of s plus 9 over s square plus 7s plus 6. Solve it, that is your function. That is your xt. That is your model equation. Solution of model equation without solving the differential equation. So now solve the inverse Laplace, please. Please solve the inverse Laplace first. So now we solve the inverse Laplace. So s plus 9 over s square plus 7s plus 6. Of course, this is of no use to us. So probably we should simplify it. So s square plus s plus 6 will be s square plus 6s plus s plus 6. Factorization. So do the factorization so that you get, for the partial fraction, you get some better value. So it will be inverse Laplace over s plus 9. What you get here? S plus 6 and s plus 1. Is it right? Right? You got two brackets. Now you can do the partial fraction. So I'll do the partial fraction here. For the partial fraction, forget about the Laplace. You will get s plus 9, s plus 6, s plus 1, a over s plus 6, b over s plus 1. Then it is s plus 9 is a, s plus 1, b, s plus 6, and then you will have, put s is equal to minus 1, this is 0, this is 8 equal to 5b, so b is equal to 8 over 5. Check by work if it is correct.
Yeah.
At last I get the value of b. I get the value of b, 8 over 5. So it is